How cool are these liquid death things? Like, I feel like I'm drinking a beer and it's just water. Cheers. All right, my name is Reah Miyara, VP of Product at Aporia. And my icebreaker is that before I ever got into data science and tech, I tried to be a DJ. Didn't work so well for me. I'm here today because I'm guilty of pushing models into production blind. So yes, I used to push ML models into production, real world systems, and kept my fingers crossed. Can I just get a show of hands how many people can empathize with that? Anybody? Thank you, thank you. But on a serious note, if you're not sure why ML observability is necessary for you, that's my ultimate objective of this presentation. Why you should care about ML observability and monitoring your models in production today. So, first off, we're all familiar with the process of the machine learning lifecycle. If you're not, I'll quickly kind of recap it for you. From data acquisition to data cleansing to feature engineering to building your model, training your model. And really everything goes smoothly in the vacuum that we know as training. But in production, you've got kind of real world uncontrollable variables. Maybe your ML model is using input data from an upstream pipeline. Maybe it's using it from several upstream pipelines. Or perhaps you have a model in production that's performing well, but it's the victim of a global pandemic. And all of a sudden, your users' behaviors are changing. And so being able to kind of deal with the ongoing difficulties and challenges of models in production is kind of why observability is extremely important. And it took the software development tool chain about a decade to do this. Everything from version control to their own type of experiment tracking or application monitoring. And machine learning is experiencing this kind of ongoing development today. So what is ML observability? Well, the first thing that generally people try to do is monitor their ML models. Now, monitoring your F1 or drift or performance, accuracy, what have you, is really just the tip of the iceberg. Observability is a comprehensive overview of your model's performance and behavior in its entirety. So everything from your raw inputs, metadata, features, actuals, and everything in between. It's being able to use your models with confidence in production and being able to quickly and efficiently improve those models when you experience a regression, whether that's in performance, whether that's in drift, whether that's in your data integrity. And so the kind of key components of of your ML observability platform should be a lot more than monitoring. Monitoring is the tip of the iceberg. And my background has come from IBM's Watson Group and Google's Research and Machine Intelligence division. And kind of no matter how big and grandiose your company is, I don't think you can get by without this. I mean, I've seen kind of companies big and small write their own Python scripts and then kind of come to terms with the fact that this is a full-time job. And so why is it important? The ability to proactively surface issues in production before a key business KPI is impacted is one you'll thank your ML observability solution for as soon as you kind of detect that issue. It's much better, believe me firsthand, it's much better than having your leadership come knock at your door and say, hey, why have my false negatives in my credit card fraud model spiked? Improving model performance, being able to identify low performing segments and being able to retrain or improve that model based on different geographical regions or demographics or user behaviors and cohorts. As well as building trust, especially in these highly regulated industries, which require audit trails and explainability. for why your model is acting in the way that it did. So again, no matter the company, big or small, everybody's a victim to embarrassing and sometimes very costly mistakes with their machine learning models. Whether it's unfairness, whether it's fairness and bias, or expensive performance degradations that people don't realize and aren't able to reconcile until weeks later. So especially in the enterprise, I think that we've got a ton of different challenges. Let's start with kind of the most obvious. When you're part of a company, an enterprise organization, you've got an enormous number of kind of uncontrollable variables that you're working with. Have it being your deployment environment or your number of data sources, where features are stored, what data you're allowed to access, who's allowed to access it. You have either scale in terms of number of models, team size, authorization, going forth and actually dealing with model prediction size and the volume that your model's responsible for. Data quality, again, you could be ingesting data from a number of different providers, and some of the most common issues are an upstream change in a schema without notifying your model. And ultimately, you're going to be the person responsible. Being able to integrate with your alerting platform, PagerDuty, Jira, being able to trigger maybe an alert so the right person is notified. Compliance and governance, again, for highly regulated industries, this is not just becoming a nice to have, this is becoming a must have. I think January 1st, New York City put into law that any decisions made by an automated system as it relates to HR must be audited by a third party. Interpretability, so being able to actually understand what's your model's return on investment. I mean, it's a simple question, and if you ask your leadership, is your multi-million-dollar investment in this particular ML team worth the payoff? And ultimately, the time to value. So hypothetically, I've convinced you, you're adopting your machine learning observability solution, but now what does it take to actually get up and running? What kind of dashboards and configurations and thresholds and fine-tuning do you need in place to actually reap the rewards? So some best practices, and I'll kind of do my best to zip through these. Mapping performance metrics to actually to things that translate to your business owner, to your particular use case. One common example that I often see is that, in a credit card fraud model, a false positive and a false negative are not worth the same. So we've all had that attempt of swiping our credit card, and the false positive, in other words, that annoying text that pops up on your phone asking you, is this really you making this purchase, right? That's a mild inconvenience. Maybe you bought a DJI robot for more than your usual average spend price and are handing it out at the data science conference. We're at the Aporia booth right there. Or maybe not, but nonetheless, that false positive is a mild inconvenience. Whereas a false negative is the machine learning model saying that your transaction is not fraud when it wasn't actually you, meaning it's a monetary loss of sometimes on the order of thousands of dollars, right? So being able to map your model's performance metrics to actual business metrics. Establishing clear monitoring and alerting goals. The most common thing that we see is people setting up monitors for all features, all datas, all segments, inputs, actuals, predictions, etc., and quickly getting fatigued by the number of monitors firing. So being able to establish monitors on the most important pieces of your ML models. It's nice if I were to tell you your model is 98% accurate, but if you're dealing with a credit card fraud model and your fraud model sees less than 2% of fraudulent transactions, then you could be missing every single fraudulent transaction and still achieve that accuracy, right? So model level performance metrics are not where it stops, it's where it starts. You need to be able to see certain metrics across segments, across low performing cohorts, and furthermore, understand prediction level objectives. Being able to look back at your insights when you're actually debugging and identifying root cause of issues in your model is another important aspect to learn from so that you don't make the same mistakes over and over again. As we know, history repeats itself. Automating your observability is another important piece, and I'm gonna kind of zip through this as I see my time running out. Explainability and collaboration. So what are the key components that are important to a robust ML observability solution? Let's start with the first, visibility. Especially in enterprises, as we're dealing with a growing number of models, a growing number of data sources, and upstream data providers, being able to have a single pane of glass, visibility to all your models, their performance, their owners or points of contact, the integration statuses, is extremely undervalued and underappreciated characteristic of an ML observability solution. But furthermore, being able to double click on an individual model and being able to see, again, what we mentioned, those global, local, and prediction level data stats and behaviors and performance metrics. So the first key component of an ML observability solution is visibility. The second piece is monitoring. Again, think of the time to value it takes when setting up monitors. So being able to select a number of out-of-the-box detection methods, compare them to different baselines. If you're looking at a reference model that if you're looking at your model that you just pushed into production, and maybe, it's again that example of a credit card fraud model, perhaps the best comparison to a baseline is not the training set because that's a high quality, oversampled corpus of data. Perhaps what you should be comparing it to is an initial model launch period, right? Being able to set up and configure monitors in an efficient fashion is kind of, one of the most key, crucial components of an ML observability solution. And I think one other thing to note is the flexibility of an ML observability platform matters. Being able to write custom metrics for custom monitors on custom segments of your data. Alerting. It's nice to have kind of a red flag waving before a business KPI drops, but it's a lot more important if I can tell you what's going on and where to look to fix it. And that's where alerting, where confident and instructive alerting comes into play. So being able to tell me that an anomaly was detected for a particular model on a particular version for a particular date, and furthermore, the rhyme or reason as to what could be causing this. Again, alert fatigue is one of the most draining symptoms of misconfigured ML observability solutions. Furthermore, once an alert is fired, being able to investigate the root cause of that issue is, again, something that's going to give you time to value. Ultimately, you're aware something is going wrong, but you don't know where and how to fix it. So being able to look at your data and identify low-performing cohorts or feature value combinations that are commonly resulting in bringing the entirety of your model's performance down. Finally, explainability. Explainability is especially important as you're integrating your model, whether you're sending in Shapley values or line values, being able to interactively understand when and why a prediction was made, a particular inference was made based on the feature value combinations across your model's input. And lastly, fairness and bias. Again, being able to write a number of different custom metrics to support parity metrics, supporting parity metrics and evaluation of different sensitive and insensitive attributes, whether that's age or sex or socioeconomic status. These sensitive attributes and your model's performance as they relate to these sensitive attributes is extremely important. And again, it's becoming no longer just a nice to have and not just the right thing to do, but law as we're seeing maturity in this space. And thank you very much for having me. I'd like to take any questions. Yes, thank you.
Thank you for the talk. Can you talk about a little bit about the alert fatigue that you mentioned and how you guys have tried overcoming that?
Yeah, absolutely. The question was to provide a little more color around the alert fatigue. I think this is one of the most common issues we see in kind of misconfigured, during the initial phase of integration with an ML observability solution, is oftentimes what happens is people will manually configure various thresholds and fine tune based on a particular period, whether it's a 2-week period of evaluation or maybe even 10 days, because it becomes extremely cumbersome. And what happens is the alerts might go away for a while, and then after, whether it's a model that's affected by seasonality or if it's simply drift over time with another slow bleeding failure, what happens is those alerts tend to creep back and in numbers. And so what we're able to do is provide you with kind of a 3-click view across your alerts. So as you are getting alerts during this initial period of a configuration, we allow you to ignore and say, hey, this is actually not an alert that I care about. We allow you to kind of mark it as a to-do and an investigation, and we allow you to resolve that issue and say, hey, thanks for letting me know. And so actually being able to train a model to identify anomalous alerts and to fine-tune that using machine learning as well.
Thank you.
Thank you very much.